The purpose of this video is to analyze the data relevant to the study that tested the hypothesis that there might be an association between changes in the weather and people's experience of acute back pain. And I've set up the data such that there are 980 participants as reported in the study, 981 participants as reported in the study. Now the study actually did something a little bit different than what I'm showing here. I've simulated data to correspond very closely to the results, but I've made things a little bit different so that it would be consistent with a simpler explanation of what actually took place. So basically the researchers measured changes in the weather, and in this fictitious setup of the data, one standard deviation change in pressure was coded as an event of 1. So that's a big change in barometric pressure. So if the barometric pressure changed by 1 standard deviation, that was coded as a weather-related event that theoretically might impact people's backs, and people would be expected to be experiencing more back pain on those days. And the second variable, which is acute back pain, is coded 10 as well, and 0 means as no, and 1 is yes, they were experiencing back pain on that day. So basically the participants were contacted on a particular day, and if they were asked if they were experiencing acute back pain that day, and the researchers dug up the meteorological data to find out whether that day in which the participants were contacted had experienced a barometric pressure change of 1 standard deviation in the last 24-hour period. So let's look at the results associated with this. We can test this hypothesis with a Pearson chi-square analysis. Click Analyze, Descriptive Statistics, crosstabs, and put barometric pressure change of a standard deviation of 1 in the rows, and columns is whether the person experienced back pain that day. Click on Statistics, chi-square, and phi. Click OK, and in cells, or click Continue rather, and cells we want to see the expected counts and the percentages of in the rows. Click Continue and click OK. And here are the results. Again, 981 participants in this study, no missing data points. Then we go over here and we find that, let me clean this up a little bit so that all the results are on the same row. So we can see that the acute back pain is in the column section, and whether there was a change in barometric pressure is a row. The best place to look is actually on this side here, the column. The percentage of people who were experiencing back pain on a day that had barometric pressure changed by 1 standard deviation was 10.2%, and the percentage that were experiencing back pain on a day that there was no change in the barometric pressure was 9.4%. And so numerically it looks like there is a numerical difference between experiencing back pain, at least a percentage difference, between experiencing back pain on a day that is associated with a change in barometric pressure. But the question is, this is actually quite a high percentage when there wasn't a change in barometric pressure. Still, 99.4% of people had an experience of acute back pain on that day. So if the theory that weather has an impact on people's backs, and people can basically predict the weather, so to speak, there should be probably a bigger difference than these two percentages. And when I tested this with a Pearson chi-square analysis, it was found to be non-significant statistically with a Pearson chi-square of 0.169, and with 1 degree of freedom, the p-value was 0.681. Again, the paper upon which this example is based, they didn't do a Pearson chi-square analysis, but they didn't find any results based on the analysis that they did. So it was basically very similar to this. And then phi is estimated very weakly at 0.013. So the null hypothesis of no difference between a change in barometric pressure and an enhancement or increased percentage of people experiencing back pain was not rejected in this case. The null hypothesis was not rejected because the p-value is equal to 0.681. It would have had to come in at less than 0.05 to suggest that these numerical percentages were different, but they're not based on these data.